Welcome to AI Dispatch, your channel for the latest AI videos on YouTube. If you don't want to miss these updates, please like, subscribe, and share. The Latent Space podcast presents Dhravya Shah, founder of Supermemory. His argument, tools like OpenClaw rely on a broken memory architecture, and fixing it demands scrapping knowledge graphs, abandoning agentic retrieval, and rebuilding from scratch. His engineering proposals run counter to industry consensus, but his credentials give them weight. Dhravya Shah is the founder and CEO of Supermemory. By age 20, he had already seen 2 companies acquired. Last year, he raised $3 million to transform Supermemory into a VC-backed, mostly open-source cloud business. His track record suggests his technical heresies deserve serious attention. Dhravya Shah's critique of AI memory systems targets a foundational assumption in data architecture. For decades, the triplet structure subject-predicate-object or entity-relation-entity has been treated as the canonical form for knowledge graphs. Shah argues this orthodoxy produces inferior results when applied to AI memory. His technical objection centers on traversal overhead. Triplet-based graphs force the system to perform deep multi-layer searches to retrieve even simple information, introducing latency that degrades agent performance. Rather than conforming to semantic web standards, he advocates building custom graph structures optimized for retrieval speed, sacrificing structural purity for operational efficiency. This architectural choice reflects a broader shift in how agents interact with stored information. Current systems, including OpenClaw, operate on a tool-based model. The AI decides when to query its memory. Shah identifies a critical failure mode in this design. If the agent does not recognize it has forgotten something, it never initiates a search, rendering the memory effectively non-existent. His alternative replaces this passive model with a hook-based architecture. Instead of waiting for the agent to request information, the system proactively injects the most relevant 2,000 tokens of dynamic context into every conversation. This eliminates the dependency on the agent's self-awareness, shifting from reactive retrieval to forced context injection. Shah's emphasis on proactive, efficient systems stems directly from how he built Supermemory. He originally developed it as a side project and tweeted that he was running the entire service on Cloudflare for just $5 a month while serving roughly 100,000 users. He even shared the full architecture diagram. That tweet went viral, and the public's attention shifted from the app itself to the infrastructure enabling it. That viral moment, which prioritized lean infrastructure over feature complexity, sets the context for his critique of AI benchmarks. Shah exposes a fundamental flaw in how the industry evaluates memory systems. In tests like long memory evil, a system achieves a higher score by extracting and storing everything. In production environments, this approach fails because extraction incurs both cost and latency. A system that wins the benchmark may be too expensive to deploy commercially. Current evaluations are gameable because they reward data hoarding rather than intelligent curation. He doesn't stop at criticism. During the interview, he delivered a moment of radical transparency. While discussing benchmarks, he deadpanned that you should not listen to him actually, then immediately introduced Memory Bench, his own open source tool built specifically to let competitors test their systems against his in the open. It was his way of mocking vendor-controlled benchmarks while building trust through action. This philosophy of curation over accumulation came from direct consulting work. After his project went viral, companies began hiring him to set up their own memory systems. Through working with these other memory companies, he learned what users truly needed. Systems that could handle updates, perform temporal reasoning, and gracefully forget obsolete information. This experience led him to a counterintuitive design principle. A good memory system must be designed to forget. Without mechanisms for forgetfulness and temporal reasoning, memory becomes a liability. The system needs to know you moved offices last week and that the old address is now stale data. Current static file systems used by Cursor or OpenClaw lack this temporal dimension entirely, leading to context pollution where old and new facts conflict. Shah's most radical claim involves redefining personalization itself. Most developers treat personalization as retrieving facts. Shah argues you need a distinct user profile, a small, persistent packet of about 500 tokens that combines static facts with recent episodic events. He uses the example of asking an AI to find the best monitor for me. A standard RAG system fails here because it searches for literal keywords. A true memory system needs to know you are a CEO, a static fact, and that you just raised funding, an episodic event, allowing it to infer you might want a high-end display. This requires shifting from searching documents to maintaining a psychological profile of the user. For developers building AI agents today, Shah's recommendation is clear. Move away from static markdown files and implement a hook system that pushes context to your model before it even has a chance to hallucinate. If you're interested in the video featured in this episode, click the link below to watch the original.